Okay, example 2. So what we do is, again, remember what the question was. The question was, find the radius of the circle and the measure of the angle in standard position for each terminal point, P. So this is a terminal point. So let's get an idea of what's going on here. It's a terminal point of an angle in standard position, which means that we started off with an initial arm coming off that way along the positive x-axis, and it is going to end up at negative 1512. So it's ending up somewhere out here. Okay, so this arm is rotating all the way around. Now I made that a little bit short. Maybe I can make it a little bit longer. So we'll bring it out here maybe. And we're going to envision this being rotated in a big circle all the way around so that the terminal arm goes through this point, which means we're going to end up here. So using a little bit of a highlighter because it might be easier. So we're taking this and we're stopping there. So we're rotating all the way around. Make that a little bit uglier so it looks better. There we go. So we're rotating, a little bit uglier here, all the way around. So the angle in standard positions here, guys, that's the angle we're looking for. And it's a positive angle because that's what an angle in standard position is, the positive angle rotating in a positive direction. Now, we know a couple of things. We know that this is negative 1512, which means that if I drop a perpendicular here, this is going to be negative 15 right there. And if I drop a horizontal here, this is going to be 12 along the y-axis, which means that this is going to be, we can talk about this as being 12 units, and we can talk about this as being 15 units. And we can use the concept that this is in a negative direction. So it's negative 15 units this way. And we're going to end up with a right triangle here. Okay, so the question's actually asking for two things. It's asking for the radius, first of all. And this radius is the same here as it is here. So if I find out this radius, it will tell me this radius. To do that, I'm going to use Pythagorean theorem again. So for r, now, it's going to be radius squared equals this length. Now, it's negative 15 units, but when we square it, it's going to be positive, okay? And this is going to be 12 squared. And so 15 squared plus 12 squared is 369 squared. We're going to square root that. And we're going to get r equals approximately 19.2, and you omit the negative. Why? Because it's a length. And again, you should be putting this in. You're in grade 11M. You're looking at going into grade 12M. You should be understanding that there's two possible answers there, and we're only using one of the answers. So now, how do we get theta? Theta's a little bit more interesting in this question because it's not in quadrant 1. Theta extends through quadrant 1 into quadrant 2. And we're going to get theta by finding something else first. I'm going to find what's called phi. Now, don't get too hung up. That's just another Greek letter that we use in mathematics, and we call it phi. And it just means an unknown angle. It's an unknown angle measure. And we use it when we've already used theta. Okay, so we're going to use it when theta has already been used in the question. So I have a theta, so I need another variable. I'm going to use phi. Okay, so let's find phi. So I've got a nice right triangle here. I can use opposite and adjacent. So it's going to be tan is going to equal 12 over, now it's negative, but remember these are lengths, so I'm not going to worry about the negative. It's actually 15 units. The length of the direction doesn't really matter. so over 15. The same argument could have been made up here. And so, oops, there we go. So angle phi is equal to tan inverse 12 over 15. So it's going to be 12 divided by 15 equals second function tan. And we're going to end up with about 38.7, or maybe, oops, phi, not theta, equals approximately 39 degrees. Well, that's phi. That's not theta. Theta is this guy. To get theta, what we do is we notice that if I had gone all the way around to here, then that would be 180 degrees rotation. But I didn't. I only went up to here. How much did we miss? We missed 39 degrees rotation. So that's going to give us an answer of approximately 141 degrees rotation. So the angle in standard position, the angle that I want, is 141 degrees, and that's here. This is the angle in standard position to get a terminal point negative 1512. So in other words, to stop here at negative 1512, we need an angle of 141 degrees starting here, going that way. Okay? Now, that's it for that question. We're good. They had 3 distinct steps though, right? You had 1 step for getting r, 2 you need to get phi first, and 3 to be able to get theta, and then probably a very good idea to have a final statement here. Okay, we're going to stop there and we'll come back with coterminal angles.